Welcome to trying to get better at sequences and series. First of all, there's a lot of different problems on this packet and in this unit. You just gotta have the feel for what you're doing for each problem. So you gotta really pay close attention to the directions and what everything means. For instance, number one is literally just an nth term formula. It doesn't say anything about it being arithmetic or geometric. It's just a sequence. And they're asking us to find the first 5 terms. So all that means is you put in a sub 1 and then you replace everything or every n you see with a 1. So basically we have 2 plus 1 all over 3 times 1. And what you get here is 3 over 3, which is obviously 1. Then we will go ahead and do this again for the second term. And we're literally just replacing those n's with 2. So 2 plus 2 all over 3 times 2. And we get 4 over 6, which reduces to 2 over 3. I'm not going to keep doing that for this one just because it is that straight up concept. Next one you'd put in a 3, then a 4, then a 5. Check the solutions in the Google Classroom and hopefully you will get the same results. Now I am going to go through all of these here because these ones, oh, by the way, this one right here was what we would call an explicit sequence. And the reason it's an explicit sequence is that you can find any term right now. I could find the 50th term very easily by plugging in a 50. All right, this one's a little different. And the reason it's different is that we have this right here, the n minus 1. So I need you to know right there, and I'm going to write this off to the side, is that if I'm ever talking about a sub n minus 1, it's 1 less than n. It's 1 less than the nth term. So I don't need to find the first term for this problem. That's 1 over 16. But most kids figure this out after a couple of tries of plugging stuff in. If I'm finding the second term, think about this. I have my formula right here for the nth term. If I put in the second term, I've already got the left side of my equation right now. So all I have to do is 8 times, and that becomes a sub 2 minus 1. Well, what is 2 minus 1? That's literally just the number 1. And then now we think, oh, what is a sub 1? Well, we know a sub 1 is 1 over 16. So this essentially becomes 8 times 1 over 16 because that is the first term. And then that becomes 8 over 16 or 1/2. Now, this is called a recursive sequence because you need the previous term in order to complete the next term. If I tried to find the 50th term right now, I would need to put in a 50 for n and get the 49th term. And I don't have the 49th term. So you have to go in order to find any term number. So if we were to keep going here, the third term would be equal to 8 times a sub 2 because 3 minus 1 is 2. Well, that's really 8 times 1/2 because that's what I have from the second term. So that becomes a 4. Likewise, the fourth term is essentially taking the number 8 and multiplying by the previous term. So once again, that would be the third term. So that equals 8 times 4, which equals 32. And then the fifth term would be equal to 8 times the previous term, which is 32. So what do we got? 256. There. All right. So that's how we do those recursive sequences. They're a little goofy. Like, look at this one. This one right here, this one right here has the first term, but it has this formula. Okay, well, you can follow this formula. It's just fine like that. I think it might be a little bit easier to think about the formula like this. The nth term is equal to the previous term. That's literally what that says there. And then if you add 4 to both sides, it'd be adding 10. So I want you to stop and think about this for a second right now. If you go ahead and really comprehend what this is saying, this says to find the nth term, take the previous term, n minus 1, and just add 10 to it. So just you're continually adding 10 to this. So basically, mathematically, if I found the second term, that would mean, if I'm looking right here right now, okay, that would mean I have to take the previous one, the first term, and I have to add 10 to it. Well, that's going to be 6 plus 10, which is going to be 16. Well, to find the third term, I'm going to take the second term, because a sub 3 minus 1. You're plugging in a 3. I mean, look at this right here. Think about it as plugging in a 3. So that would be a sub 2 plus 10. And the second term is right there. It's 16. So we're going to get 26. And then the fourth term, we will get 36. And then the fifth term, we will get 46, because it's the previous term plus 10. So that's a recursive sequence, and that one ends up actually being an arithmetic sequence, because there is a common difference of 10. All right, geometric sequence now, where we have a term and we have an R value. All right, well, you can definitely just, if we're multiplying left to right by 1/2, that means we're dividing by 1/2 the other way, or multiplying by 2. But using our formula, we can take, the nth term equal to the first term times r raised to the n minus 1 power, and we can literally use this information right here. So by establishing the 13th term, because that's what we have, I don't know the first term. I do know that this is 1/2, but by establishing this, the 13 is the n value. So this becomes 13 minus 1, which is 12 here. Okay, so here we go. We got 13th term. Oh, that's really just 10. So we got 10 equal to the first term. And then we have 1/2 to the 12th power. All right. So let me see what I got here. We could do 0.5. And then the crowd went silent because, oh, here it is. I think I can make it to there we go, to the 12th power. And we've got this, if we don't go to a nice, neat fraction, we go to a decimal. I didn't pull up my other calculator right now. But then we want to take 10 and divide by our answer there. So I don't know how we can do that on here because I'm not smart enough to figure that out. Whoops, and then I lost my number. So let me try this again a different way. I'm going to take 10 and I'm going to divide by, putting this in parentheses, 0.5 raised to the, 12. Okay, so if you look here, we got 10 divided by 0.5 raised to the 12th power. And then if I hit enter, that's going to come out to, sorry, I didn't show all my work here. I wasn't showing it all, but what I was saying here is that this number I divided both sides by. I just did that all in one calculation. So I would get my first term of, what was that, 40960. Okay, now the rest of them's easy. All right, so if you think about it, all I got to do is take that number and times 1/2. So times 0.5, and I get myself 2480. And then I'm going to take that and multiply by 0.5. My third term would be that. And then my fourth term would be that. And then my fifth term would be that. All right, so you guys can go through and finish all of those. But basically, again, the directions were just to find the first 6 terms. Okay, so, I'm sorry, 5 terms. I think I did find the first 6 on my answer key, but that's okay. You get the idea. If you can get to 5, you should be able to get to 6. Okay, so here we are, the arithmetic sequence. So the formula we used was to find our common difference first, and what we did here is we took the 338, and that would be minus a negative 70, so just be careful, that's actually plus 70 in this case. The reason we do that is because we want to find out how much we added. Obviously, we added 70 to get to 0, and then another 338 to get there. So basically, we want to figure out how much we added. And then if we take 200 minus 166, we're basically figuring out how many times did we do that addition. Because arithmetic means we are adding the exact same thing each time. So if we find out what we added on top, which is 408, and then we divide that by 34, and we're figuring out what we are actually adding every single time. So 408, and then I divide by 34, and I get my 12. So my common difference is 12. Well, again, the directions for this section were just to find the first 5 or 6 terms, whatever you want to do. So basically, we could come up with multiple ways to kind of think this through, but if we're using our formulas, this finds any term of an arithmetic sequence. Okay? So there's our formula. Well, I'm going to establish, once again, if I establish, this right here as one of these, I've just established the n value as 166. So most of us picked the first one. So I'm going to make this negative 70. If you're wondering why I didn't make that 166, it's because the actual, if I replace the n with 166, that term would be negative 70. Well, I don't know my first term, and I'm going to add to that, well, here we go, 165. And the reason that is because I take my n minus 1. I establish the n as 166. So now I'm here. And then I multiply by my d value of 12. All right, so here we go. Take out our trusty calculator. We got ourselves negative. Is that right? How to do the negative? Nope, right there. So I got 70. I got negative 70. And I am going to add to that 165 times 12. Close off those parentheses and hit enter. So I got 1910. So my first term would be, did I do that correctly? I don't think I did. I needed to subtract that. It should be a negative value. So I apologize. I'm going back in time now. I take a 70 negative, okay, because I got the negative 70 right here, and I'm actually going to subtract because I got to subtract this product from both sides. The first term should be a negative number, obviously. All right, so then I got to subtract, and then I'm going to put in parentheses 165 times 12. Close off those parentheses. Then I'll hit enter, and there it is, the negative 2050. So I got negative 2050, and then how would I find, the second term? I'm going to add 12 to that, and then add 12 and add 12. I'll let you look at the answer key for that, but basically to get the other terms, you just keep adding 12. All right, this is a wrinkle for a lot of kids. Geometric sequence where we have this goofy fraction and that goofy fraction. Well, don't forget, this is left of that. There's a gap. There's a sixth term, there's a seventh, an eighth, and then a ninth term over here. All right, so what we got to do is we got to think of the concept. I hope this helps. I'm going to do this in red right up here. It's a really simple concept. If we have 2, 4, 6, 2, 4, 8. I got to think geometric here. And then we have 16, and then we got 32. All right. I just want you to think about what this problem's saying. They're saying like there's a term 6, there's a missing 2 terms, and then another term. So it's like I don't know these two here, but I know this term and I know this term. But I don't know what I'm multiplying by. Well, if you think about it, you start at the number 2 and you multiply by something to get to this term. Then you multiply by something to get to this term, right? So we multiply by r, we multiply by r, and then we multiply by r one more time. So times r, and then by the time we do that, we actually achieve the 16. So if we were to write this in an equation, it'd be 2r cubed equals 16. Well, then I can divide both sides by 16. By 2. And then I would get r cubed equals 8, and you can clearly see that r is going to come out to 2, which is exactly what it was. Now, I just do that little preview to show you this here is because these numbers are a little bit uglier and you might not make as much sense about it, but that's the process. All right, so here we go. We're going to start at the value of 3 over 128. And what we're going to do is we're going to multiply by r. How many times? Well, if we look at this, we're going from 6 to 9. That's a gap of 3. That means we multiplied by r 3 times because there's a difference of 3 there. So again, that's going to be r cubed. And after we take this value times r cubed, we achieve the right value. So 3 over 8192. All right, so now we divide both sides by that, which is really the exact same thing as multiplying by the reciprocal. It works out a little bit nice and neat there. So when I multiply by 128 over 3, those 3's are going to cancel. You're actually going to get r cubed to come out to 1 over 64. And then when we take the cube root of both sides, we're going to get an r value of 1 over 4. Okay, well, now that we have the r value of 1/4, there's a couple of ways of going through this problem. Since 6 is so close to the first term, it's not that far away, it would not be terrible, since we're multiplying by 1/4, we could be dividing by 1/4, which is the same as multiplying by 4 backwards. So you could take this and multiply by 4 to get your fifth term, multiply by 4 to get your, because that's what we're supposed to do, right? List all of these out. So multiply by 4, 4, 4, all the way down to the first term. I will, since I'm doing a video here, show you the mathematical way, the formula way. Here's our formula. Okay, you feel comfy with doing whatever you want when that's so close to the first term. But basically, I'm going to establish this term as 3 over 128. I mean, if I do that, I've just established the n value as 6. So now I have, hey, I don't know what my first term is. I know my r value came out to 1/4. And then I have n minus 1. Well, n is 6, remember. So it would be to the 5th power. Okay? So what do we got here? We got 1/4 times 1/4 times 1/4 times 1/4. We're going to keep doing that, but we can divide both sides by that. Again, my non-fancy calculator can probably do that just as fine. So I'm going to have 3 divided by 128. I'm going to hit enter on that. And then I want to divide that answer by 0.25 raised to the, what was it, 5th power. And I go like that, and I hit enter, and that comes out to 24. So that's nice. So 24 is my first term. So basically, if I was to find my second term, I'd multiply by 1/4. So this is going to be 24. Next one would be 6. Next one would be 6 times 1/4, or 3/2. And then you can see where this is going to get all those 3's on top, because we keep multiplying by 1/4, 1/4, 1/4. All right? All right. I'm going to shut off page 1 here.